In our 6th lecture video on force, we will discuss total forces in one dimension. Our goal in this video will be to find the net force acting on an object. When forces act in the same or opposite directions, the net force can be found by adding the forces that act in one direction and subtracting the forces that act in the opposite direction. As an example, if we wanted to find the net force on this carriage, we would add the force acting in one direction to the left. 25 pounds plus 35 pounds equals 60 pounds. We would then subtract the forces acting in the opposite direction, which is 45 pounds. 60 minus 45 would give us a net force of 15 pounds acting to the left in the direction of motion. Let's take a look at an example of the idea of net force. A small car with a mass of 1,150 kilograms has to be pushed into the shop with a force of 975 newtons. If the frictional force between the tires and the floor is 650 newtons, what is the acceleration? In this problem, we first need to find the net force acting on the car, and then we can use Newton's second law of motion to calculate the acceleration of the car. Looking at our force diagram, we see that the force of the push acts in one direction and the frictional force acts in the opposite direction. In order to find the net force, or the sum of the forces, we will take the force of the push, which is 975 newtons, and subtract the frictional force of 650 newtons acting in the opposite direction. This gives us a net force acting on the car of 325 newtons. Now that we know the net force, we will record the rest of the information we were given. We just found the net force to be 325 newtons, and the mass of the car is 1,150 kilograms. We are trying to find the acceleration. The basic equation for Newton's second law is that the net force is equal to the mass of the object times its acceleration. Since we want to find the acceleration, we need to rearrange to find a working equation written in terms of the acceleration. If we divide both sides by mass, we see that acceleration is equal to the net force divided by the mass. Our next step is to substitute in our data. The net force is 325 newtons, and we will divide that by the mass of 1,150 kilograms to get an acceleration of 0.283 meters per second squared. This concludes our discussion on net force in one dimension.